Machine learning is a branch of artificial intelligence that enables computers to learn from data and improve over time without being explicitly programmed. Instead of following strict instructions, these systems analyze patterns and make predictions or decisions based on the information they receive. This technology powers many of the smart features we use daily, from voice assistants to recommendation engines. In this video, we'll explore the basics of machine learning, how it works, and why it's transforming industries worldwide. Let's start by understanding the core concept behind this fascinating field. Roots of machine learning trace back to the mid-20th century, when pioneers began exploring ways for computers to mimic human intelligence. Early experiments focused on simple pattern recognition and rule-based systems. Over the decades, advances in computing power and the availability of large datasets have propelled machine learning into the spotlight. Today, it's a driving force behind many technological breakthroughs, shaping the way we interact with the digital world. Understanding this history helps us appreciate how far the field has come and where it's headed next. Its core, machine learning involves feeding data into algorithms that identify patterns and relationships. These algorithms adjust themselves based on the data they process, gradually improving their accuracy. For example, a machine learning model might learn to distinguish between cats and dogs by analyzing thousands of labeled images. Over time, it becomes better at making correct predictions, even when faced with new, unseen examples. This process of learning from data is what sets machine learning apart from traditional programming. Machine learning can be divided into several main types: supervised learning, unsupervised learning, and reinforcement learning. Each type uses different methods to analyze data and solve problems. Supervised learning relies on labeled data, unsupervised learning finds hidden patterns in unlabeled data, and reinforcement learning teaches machines through trial and error. Understanding these categories is essential for grasping how machine learning is applied in various real-world scenarios. Supervised learning is one of the most common approaches in machine learning. In this method, algorithms are trained using labeled data, meaning each input comes with a known output. The model learns to map inputs to outputs, making it possible to predict outcomes for new data. For instance, email spam filters use supervised learning to classify messages as spam or not spam based on examples they've seen before. This approach is widely used in tasks like image recognition, speech recognition, and medical diagnosis. Supervised learning takes a different approach. Here, the data provided to the algorithm is unlabeled, meaning the system must find patterns and relationships on its own. This method is often used for clustering similar items or reducing the complexity of data. For example, unsupervised learning can group customers with similar buying habits or identify trends in large datasets. It's a powerful tool for discovering hidden structures in data without prior knowledge. Reinforcement learning is inspired by the way humans and animals learn from experience. In this approach, an agent interacts with its environment, receiving rewards or penalties based on its actions. Over time, the agent learns to make better decisions to maximize its rewards. This type of learning is commonly used in robotics, game playing, and autonomous vehicles. It's particularly effective for tasks that require a sequence of decisions and adaptation to changing conditions. Machine learning relies on a variety of algorithms, each suited to different tasks. Some popular algorithms include decision trees, support vector machines, neural networks, and k-means clustering. These algorithms help computers classify data, make predictions, and find patterns. The choice of algorithm depends on the problem at hand and the nature of the data. Understanding these foundational algorithms is crucial for anyone interested in machine learning. Data is at the heart of machine learning. The quality and quantity of data directly impact how well a model learns and performs. Clean, well-organized data allows algorithms to identify meaningful patterns and make accurate predictions. In many cases, collecting and preparing data is the most time-consuming part of a machine learning project. Without good data, even the most advanced algorithms can't deliver reliable results. Build a machine learning model. Data is typically split into two sets: training and testing. The training set is used to teach the algorithm, while the testing set evaluates its performance on new, unseen data. This process helps ensure the model can generalize and make accurate predictions in real-world situations. Properly splitting and using data is essential for building trustworthy machine learning systems. Feature engineering is the process of selecting and transforming data to improve a model's performance. By identifying the most relevant features or variables, we help the algorithm focus on what's important. This step often involves creating new features from existing data or removing irrelevant information. Effective feature engineering can significantly boost the accuracy and efficiency of machine learning models. Evaluating a machine learning model involves measuring how well it performs on new data. Common metrics include accuracy, precision, recall, and F1 score. These metrics help us understand the strengths and weaknesses of a model, guiding further improvements. Regular evaluation ensures that models remain reliable and effective as new data becomes available. Two common challenges in machine learning are overfitting and underfitting. Overfitting occurs when a model learns the training data too well, including its noise, and fails to generalize to new data. Underfitting happens when a model is too simple and can't capture the underlying patterns. Balancing these issues is crucial for building models that perform well in real-world applications. Neural networks are inspired by the human brain and are a key technology in machine learning. They consist of layers of interconnected nodes, or neurons, that process information in complex ways. Neural networks excel at tasks like image and speech recognition, where traditional algorithms struggle. Their ability to learn from vast amounts of data has driven many recent advances in artificial intelligence. Deep learning is a subset of machine learning that uses large neural networks with many layers. These deep networks can automatically learn complex features from raw data, making them especially powerful for tasks like language translation and autonomous driving. Deep learning has enabled breakthroughs in fields such as computer vision and natural language processing, pushing the boundaries of what machines can achieve. Machine learning is all around us, powering many of the tools and services we use every day. From personalized recommendations on streaming platforms to voice assistants like Siri and Alexa, machine learning makes technology smarter and more responsive. It's also used in navigation apps, fraud detection, and even medical diagnosis. These real-world applications show how machine learning is making our lives easier and more efficient. Healthcare machine learning is revolutionizing the way we diagnose and treat diseases. Algorithms can analyze medical images, predict patient outcomes, and even suggest personalized treatment plans. These tools help doctors make more accurate decisions and improve patient care. As machine learning continues to advance, its impact on healthcare will only grow, leading to better outcomes for patients worldwide. Machine learning is transforming finance and business by automating complex tasks and uncovering valuable insights. In finance, algorithms detect fraudulent transactions, assess credit risk, and optimize investment strategies. Businesses use machine learning to analyze customer behavior, forecast demand, and streamline operations. These applications help organizations make smarter, data-driven decisions and stay competitive in a fast-changing world. Transportation industry is embracing machine learning to enhance safety, efficiency, and convenience. Self-driving cars use machine learning to interpret sensor data, recognize objects, and make driving decisions. Airlines optimize routes and schedules, while logistics companies predict delivery times and manage fleets. These innovations are making travel safer and more reliable for everyone. Despite its many successes, machine learning faces several challenges. These include the need for large, high-quality datasets, concerns about bias and fairness, and the difficulty of interpreting complex models. Addressing these challenges is essential for building trustworthy and ethical machine learning systems that benefit everyone. As machine learning becomes more widespread, ethical considerations are increasingly important. Ensuring fairness, transparency, and accountability in algorithms is crucial to prevent discrimination and build public trust. Researchers and practitioners are developing guidelines and tools to address these issues, making sure machine learning serves the greater good. Big data plays a vital role in machine learning by providing the massive amounts of information needed to train powerful models. With more data, algorithms can learn more complex patterns and make better predictions. Advances in data storage and processing have made it possible to analyze huge datasets, unlocking new possibilities for machine learning applications. Cloud computing has made machine learning more accessible by providing scalable resources for data storage and processing. Researchers and businesses can now train and deploy models without investing in expensive hardware. This flexibility accelerates innovation and allows more people to benefit from machine learning technologies. The machine learning community benefits from a wealth of open-source tools and libraries. Popular frameworks like TensorFlow, PyTorch, and Scikit-learn make it easier to build, train, and deploy models. These tools foster collaboration and innovation, helping both beginners and experts advance the field. Machine learning is poised to transform even more aspects of our lives in the coming years. Advances in hardware, algorithms, and data availability will drive new breakthroughs in fields like healthcare, education, and the environment. As the technology matures, we can expect smarter, more capable systems that help solve some of society's biggest challenges. If you're interested in learning more about machine learning, there are plenty of resources available. Online courses, tutorials, and communities can help you build foundational skills and start experimenting with real-world projects. Whether you're a student, professional, or hobbyist, machine learning offers exciting opportunities to explore and create. Collaboration is key in the machine learning community. Researchers, engineers, and enthusiasts share ideas, datasets, and code to push the field forward. Open competitions and collaborative projects encourage innovation and help solve complex problems. By working together, the community accelerates progress and ensures machine learning benefits everyone. Education is another area where machine learning is making a big impact. Adaptive learning platforms use algorithms to personalize lessons, helping students learn at their own pace. Teachers can use data-driven insights to identify areas where students need extra support. These tools make education more effective and accessible for learners everywhere. Machine learning is helping address environmental challenges by analyzing data from sensors, satellites, and other sources. These models can predict weather patterns, monitor wildlife, and optimize energy use. By providing actionable insights, machine learning supports efforts to protect the planet and promote sustainability. Summary: machine learning is a powerful technology that's changing the world. From healthcare and finance to education and the environment, its applications are vast and growing. As we continue to develop smarter algorithms and gather more data, the possibilities for machine learning are nearly limitless. By understanding the basics and staying curious, anyone can be part of this exciting journey into the future of intelligent technology.